So according to CIP rule, we are saying that the fourth priority group should be above the plane or below the plane. If it is below the plane, R configuration remains R configuration, S configuration remains S configuration. And if the fourth priority group is above the plane, R configuration changes to S, S configuration changes to R. But again, this is one more special case when a lowest priority group is in the plane. What will happen? How you are going to assign the configuration? So this is the solution. You are going to rearrange the position of atoms to assign R or S configuration to the molecule. So consider this example. Do we have chiral center here? Yes, the carbon situated at the center is nothing but your chiral center. What are four different groups attached? These are hydrogen, bromine, chlorine and fluorine. These are four different groups attached. What is the priority order? This bromine is the first priority group, then chlorine, then fluorine and hydrogen. So these four numbers we have written. Bromine is having first priority, chlorine second, fluorine third and hydrogen is fourth priority group. Now look at fourth priority group. Do we have this fourth priority group above or below the plane? No, it is in the plane. How? Because we have shown this bond with simple line. As we have said this in the second slide, that if the bond is shown with simple line, it is indicating the bond is in the plane. And if it is shown by this wedge bond, then it is above the plane. If it is dotted bond, then it is below the plane. Means these two bonds, wedge and dotted, are out of the plane, while this simple line indicates the bond is in the plane. Now in this example, we have fourth priority group in the plane. So how will you find the R or S configuration? So here is the solution. After rearranging the molecule, you will get either R or S configuration. How you are going to rearrange? See, here in this example, hydrogen is in red color and fluorine is in blue color. So you are just going to rearrange the position of this atom which is below the plane with the fourth priority group. So here I have interchanged the position of fluorine and hydrogen. Okay, we have interchanged the position. Now fluorine is in the plane and hydrogen is below the plane. Okay, now we can assign configuration to this rearranged molecule. Okay, again the priority order will be same. That is, bromine will have first priority, chlorine will have second priority, fluorine will have third priority and hydrogen will have fourth priority, and we have hydrogen below the plane. Now we can easily assign the configuration for this rearranged molecule. Okay, so we'll draw an arrow going through 1, 2 and 3. It is moving in anti-clockwise manner. So the answer can be S configuration for this molecule. How will you confirm the answer? By looking at fourth priority group. Do we have fourth priority group below the plane? Yes. After rearranging, we have got this fourth group below the plane. So the answer for this rearranged molecule is S configuration. But we are not interested in this rearranged molecule. We are interested in this original molecule. So once we have got the configuration for this molecule, the original molecule will have opposite configuration to that of rearranged molecule. So if this rearranged molecule is having S configuration, what will be the configuration of original molecule? It will be opposite to that of S, means this molecule will have R configuration. This is very, very important special case which we have to consider. Now this is the last case. When a chiral center is attached to same atom or group of atom, we have to consider the next atom. Now look at this example. Do we have chiral center here? Yes, at the center we have this chiral center. To which four different groups it is attached? It is attached to aldehyde, carboxylic acid, hydroxy group and hydrogen. These are four different groups attached. What are four different groups? Aldehyde, carboxylic acid, hydroxy and hydrogen. Then this is your first priority group. Hydroxy group is your first priority group because the chiral center is directly attached to oxygen. and hydrogen will be your fourth priority group. No doubt about this. But what about second and third priority group? Because the atoms which are attached to chiral center are same. These are carbons. Rather, the next atom is oxygen. So we can see we have C double bond O and C double bond O groups common. This is called as carbonyl group. So in aldehyde and carboxylic acid, we have carbonyl group common. So what we will consider now? Look here, we'll consider the next atom which is attached to carbonyl group. So in carboxylic acid, the next atom is oxygen, and in aldehyde, the next atom attached to carbonyl is hydrogen. So who will get higher priority? Of course, carboxylic acid will get higher priority because carbonyl group is attached to oxygen, and third priority group will be aldehyde because carbonyl group is attached to hydrogen, and fourth priority group is hydrogen. Now we have drawn this arrow. The job is easy now. The arrow moving through 1, 2 and 3 is moving in clockwise direction, and the fourth priority group is below the plane. So what will be your answer? The answer for this configuration is R configuration. I hope you have understood RS configuration and all the special cases. So thank you very much for watching my video. If you have any doubt, you can write in the comment box. Thank you.